its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listeners.
Hey everyone, there you go. Hey everyone, you are back with David Mackey's Shiny Side Out on Revolution Radio, the number one listener-supported talk radio on the net. So push the donate button. You can do that. Access the archives for free. Get yourself some merchandise, some great merchandise, some really good merchandise. Get that from the station's website. A t-shirt, a mug, or anything you like. I'm going to thank you very much also for tuning in, for listening, for liking, subscribing, sharing, and commenting on our videos, please, if you can. That'd be great. I'm saying this because this is a whole new hour, and I played the intro music just like normal. However, this is episode 696. 690 and 600. If Meki were here, sadly he isn't. He's not feeling very well. Wish him a quick healing process, and he'll hopefully return for Tuesday 7 a.m. for Plato's Cave. That's Eastern Standard Time in the US, where you can have breakfast with us, so to speak. But it's not breakfast at our time. It's 9 p.m. on Monday. No, 9 p.m. on Tuesday. That's when it is, when it's your 7 a.m. Eastern. So, we've seen the whole day already. We're going to bed, and you guys are waking up. That's the best way to put it. Thanks also for listening to Revolution Radio. And I'm going to start. Guess what it is? We're talking about ETs, the extraterrestrial question, the rational and logical approach. That's what we're talking about. T.S. Eliot once said, "We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time." Isn't that very interesting? You could say the same about traveling anywhere. When I was 15, I went to school in California from Australia. Stayed at my friend's parents. I stayed at my parents' friend's house. That's accurate. And I went to school at Canyon High School in Southern California. Very nice. I loved every minute. It was a great time. Wish I could do it again. I wish it was longer. And I wish I graduated in the US and maybe lived there. I would. I really would have. I think that the time that I was there, it was the same time they were making Fast Times at Ridgemont High, the movie. A couple of schools over. It was a lot of fun. But anyway, having said all that, when I came back, I knew then what my life was here, because I'd seen somewhere else. I had the life experience of somewhere else, and when I came home, I realized what I had, and I realized it like I saw it for the first time again. So that for me was very powerful. It was a great thing to have been able to be a part of. It wasn't an exchange system that I went through, but I do love the States, and I don't like California so much because of its regulations and cars. Certainly the restrictions on motor vehicles, don't like it so much, though America has some of the best muscle cars on the planet. I do like Australia's history of muscle cars, but America's it's just a bit glossier, I'll tell you, a bit more variety. And I wish that there were more people with the right kind of wages that could have bought more vehicles of the type that I'm more inclined to purchase here. It would have been a better time. Now, because there've been more on the roads, and every single year we lose more and more of them to the wreckers or the junkyards because they've been totaled. And there's so few of them now. If I had enough money, say I had a billionaire, say I had a billionaire, say I had $1 billion, I would resurrect one of the car companies and recover their molds if they still had them, or their presses, and make the cars again. I would just make the same model. Why not? Why do we have to have different models every single year? Why can't we learn and just make that model better? Just keep it going. Like, the old red tractor with the big wheels at the back, the small ones at the front? Do you know that China bought the rights to continue to produce those, despite everyone else moving on to bigger and better things? Why let someone else do it? You can just do it yourself. There's clearly money in it. They're doing it. So that always annoyed me. At least I can still buy some of the bonnets and guards before they're gone, because, rust. Right? In America, you can still buy the subframe of any of the muscle cars, because salting the roads for ice and snow corrodes the dickens out of them. So they're still available. You can still buy them. There's still an aftermarket, surge in being able to restore these cars, and you can almost buy the whole thing. I know you can still buy a Jeep in a crate. That's really cool. Still buy those. Like World War II and Korean War style Jeeps. They're fantastic. I've seen even they have a like in Olympics, it's a competition sport where they have two Jeeps side by side and two teams, and the team of military people have to dismantle the Jeep into its components, run the components downfield, I don't know how far, maybe 100 yards or 50 yards or something, and then reassemble the vehicle again. And it's only a minute or two or something and they've done it. Isn't it crazy? How good is that? You can't do that with a Humvee, I'll tell you. But of course the Humvee is much safer, but there's a time and place for everything. I am going to read you some quotes now from the show notes. Come, let me show you what you may be saving Earth from. Would you like to see an Arcturian? A live Arcturian? Why? Sure, why not? The sphere that was Meki, it says, floated across the room, and Keith followed. A door swung open, revealing, just beyond it, a second steel-barred door that led to a cell. With the opening of the door, a light flashed on just inside the cell. Keith took a step closer to look through the bars. He took a step back, several steps, even more quickly. He felt as though he were going to be sick at his stomach. He closed his eyes and swayed dizzily. Horror and nausea almost blanked him out. And he had only a quick, indistinct glimpse of part of the Arcturian. He didn't really even know what an Arcturian looked like, but he knew he didn't want to know. That even seeing one behind bars and helpless might drive a human being mad. It was alien beyond all imagining. What a Mad Universe by Frederick Brown. And that's in a bridge version. There's a lot of lines missing from it in that version there. The problem of our place in the universe, extraterrestrial civilizations, visitations, UFOs, USOs, unexplained phenomena, and stories thereof that go back into the dim and distant past of our species are fundamentally to our very existence. They're fundamental to our very existence. We must find answers, and we must find out soon. Unfortunately, there are complexities at play here that most of us do not consider. The shiny side out, that's Meki and I, will attempt to shed some light on the rational and logical explanations that offer themselves up to us. The Earth as we know it is populated on the surface. Naturally, many creatures and plants live below in the oceans and in the bowels of the Earth. What if humans that live on the surface are but third world nation players in comparison to the civilizations that dwell under the ocean or within the Earth? The surface, in other words, is the true developing world. A lot of strange events and activities would start to make sense if that were the case. The obvious anthropomorphic problem with alleged ETs, constant sightings of USOs, they're underwater submerged objects, highly advanced tech effects, Skinwalker Ranch, Bigfoot encounters, etc. USO encounters, disappearances in national parks, stories on inner Earth societies, civilizations and cities beneath the Earth. Mutilations. Well, I don't even know. I think I've got my brain rewired so that I am imagining in my normal process of thinking. I think that's now moved forward another notch. I've been a little creative recently, and I've renewed my music writing software. Some music on Spotify that I've written from 25 years ago or greater, nearly 30 years ago. So if you're interested, have a listen to those. I'm not going to claim that they're fantastic. It was a different era, a different time, and we weren't a resident band, but we played to an audience at a Sunday kind of like chill out for anyone who went out clubbing that night. It was 30 years ago, and it was fun. There were a lot of people there in all manner of thought, say, and so the music we made then was live, and we had some recordings of those, and I recreated some of them from as best as we could remember as they went. So that's what I've posted, because it's me. My friends, I had a singer, but I don't have any of the audio from her mic, and it was a lot of fun. Anyway, back to the show notes. So the mutilations and abductions and seductions, there was checking on genetic experiments, checking on introduced livestock. Do crop circles fall into the same category? Why would not non-terrestrial races give a thought to cows or crops, for that matter? Why would they? What concern would they have? What possible interaction could they want with a cow? Maybe maybe the cows rule the world, and we don't. We keep them alive, feed them, they breed, they're happy. It would make sense if we were talking about a checkup on introduced species after the Great Catastrophe or thereabouts. I suppose that's a good way of looking at it. There were stories during the Great Catastrophe, one of the floods, where there was a group of people saved by like a metal floating boat. En masse, people were collected up and saved from the catastrophe. These ancient stories tell us that domesticated animals and agriculture were taught to us by gods. The Anunnaki, there's depictions of cheetah with Anunnaki, and they're about the size of a house cat to humans in proportion. But it's a cheetah. It's crazy big. But these Anunnaki were huge. Think about that. And it was told to us by them that we should have these domesticated animals. What about interbreeding? That's another story we hear a lot about, both in modern times and ancient accounts. Any species not native to this planet coming here interbreeding with us is laughable, you might say, unless there was a seeding event in the dim and distant past. Even closely related species today, such as horse and donkey, can only produce sterile mules. The chance of a truly extraterrestrial race, no link whatsoever to us, being able to interbreed with us is non-existent. It just could not be possible. Think about that. Meki and I, we are not disputing the existence of the above-mentioned phenomena, such as Bigfoot, UFOs, USOs, etc. In fact, Chinese Side Out firmly believes that we are living in a multiverse far stranger than any of us can begin to imagine. I should have my phone completely off and silent, but every once in a while something pops up, so I wonder if that's someone watching and messaging me. The problem lies in the vastness of space, and no, not just the distances involved, but also the volume of stars and potential planets. The Drake equation, for that matter. The distance issue, we think, is not of major importance. Faster than light travel is only a problem that needs solving, no matter how fundamental we think the speed of light limit is. Certainly, quantum entanglement has shown us that we do not understand space like we thought we did. It all seemed, before we discovered the double slit experiment problem, we thought everything was worked out. Einstein looked at the double slit experiment and goes, that's too hard. That breaks my relativity entirely, because it doesn't make any sense. It's spooky action at a distance when he's talking about entanglement. How can that even be possible? So entanglement seems to use subspace to communicate. You've got to think about the idea of subspace. It's a plane that doesn't exist inside our reality, but two things that can be connected in subspace. That means outside of our reality. Because we have a limit, science has set a physical limit of the speed of light. That nothing can go faster than that. I disagree, but that doesn't matter whether I agree or not. Because if you were in a spaceship and your spaceship was as big as this solar system, just for example, and you were going at the speed of light, where time for you would have come to a complete stop. You're moving, you're going at the speed of light, fantastic. And if you had a ball, if you held a ball in your hand and you threw it forwards towards the direction of your motion, then that ball would in effect be going faster than the speed of light to an observer. So I don't believe it's a limit. We thought a long time ago, back in the 1900s, that if you were in a train that was doing 23 miles an hour and you opened the windows, there'd be sufficient vacuum to suffocate everybody in the train. That's what my grandmother told me was the idea at the time. She said, of course, it's nonsense, we discovered, because that never happened. But we hadn't gone faster than that to be able to, inside a vehicle, to be able to test that hypothesis. And so the belief was there. It was on the table. This is what people thought was going to happen. Until we are able to, or capable, technically capable of testing whether the speed of light is truly a barrier, like the speed of sound. Oh, you can't go faster than the speed of sound. And then we went faster than the speed of sound. You can go faster than the speed of sound. You just can. It's not a limit. It's a design limitation around the capability of a wing to support lift and the buffeting and the pressures at going that speed. Also the friction which happens that causes heat. They're just design principles now that we understand what a faster than speed of sound jet's wing cross section must look like. It's not slow speed cross section, which kind of looks like if you've cupped your hands slightly, where you have a greater amount of displacement on the top half and a flatter bottom half, or super slow speed where you have a concave surface underneath and a convex surface above, which is going to enable you to get more lift at very slow speeds. But almost a symmetrical wing if you're going faster than the speed of sound. Think about those. They're only design limitations that we have to work through. So if you're setting a speed of light restriction on yourself, is it really a restriction? I don't think so. I'm just putting that out there. Some things naturally might only be able to go that speed. Naturally, like light. But that's the speed that light travels. And it could simply just be an error in our equation. The equation might be close to reality, but may require some extra components like E equals mc squared. That's the energy is equal to the mass times the speed of light squared. C being the speed of light in that equation. And when you start to get large numbers, it seems as though the amount of energy that is required to go faster is exceedingly impossible or close to impossible until it reaches impossible at the speed of light, which is infinite. It appears as though it would be almost infinite amount of energy required, or your mass, if you put it around the other way, your mass would become infinite, which also doesn't make sense. It seems to be a limitation to the equation, and we'll only discover what it means once we've got to that point. If you can simply pull, anchor, let's say we advance past this by doing something else, just bending space. We haven't effectively broken the laws of or the limitations of the speed of light. You can anchor yourself somehow, which we haven't worked out, to where you are, pull your destination to you somehow, which we haven't worked out, and then simply, since you're holding both of those together, let go of where you are, and suddenly, anchored to your destination already, you appear from the observer's point of view to fling like you've been launched out of a catapult. You fling yourself to your destination, but in effect, you haven't moved at all. Isn't that amazing? I think that is so cool. It's a great concept. And if only Oh, just reading it. Uh, so, if only that were a thing. That, if I could say anything, that's what I believe is the method of travel, which it's working physics outside of the limitations of moving, since you don't physically fly from one place to another. You bend space, and then you're there. If that makes any sense to anybody but me, then you tell me. I'll debate this as much as you like. So comment below. Now, the problem lies in the vastness of space, not just the distances involved, but also the volume of stars and potential planets. The distance issue, we think, is not of major importance. Faster than light travel is only a problem that needs solving, no matter how fundamental we think the speed of light limit is. Certainly, quantum entanglement has shown us that we do not understand space like we thought we did. I'm reiterating that because I think it's important after what I've said. In years to come, we will look back upon this period as we are now looking back to the 18th and 19th centuries, where trains going faster than 80 miles per hour was actually 23, and heavier than air powered flight were thought to be impossible. The Montgolfier brothers in France proved that lighter than air travel was possible with their balloons, heavier than air flight. We didn't have the material science or the machine science to be able to produce enough thrust light enough to be able to be heavier than air travel. It was the petrol motor with a beautiful wooden blade, fan blade, and string and very thin wood using string or wires. The beautiful engineering about being able to use something either for its compressional strength or tensile strength, that's pulling at it, tensile, to be able to then have a light frame with cloth over that to produce the wing rather than carving the whole thing out of wood, which would be unimaginably heavy. So we added strength, durability, lightness, and with a power system that allowed us then, through clever engineering, to be able to fly heavier than air. And we never look back. It wasn't even 100 years, and we had rockets with a whole new kind of science. We had jet aircraft. That's just amazing. That's so amazing we had jet aircraft in a way of being able to be more fuel efficient per pound of thrust than ever before. It changed our landscape. So this does not mean that we can ignore the physical facts of the universe we inhabit. It is a vast and chock full of stars, and probably life as well, and action-packed with planets. This very vastness and volume of planets is what we are addressing here. The question remains, why is the vastness of space? So why in the vastness of space would anyone pick Earth as a place to visit and investigate with great diligence? And of course, this is on the ET realm of existence. Why would they come here? What would be special about us enough? I grew up and always thought this was kind of like a zoo of saved species from other planets whose star went supernova, and at the right moment, some of their life, the different kinds of life, were spread amongst the other inhabitable planets without technology in order for them to It's a stupid thought. I'm not saying it's real. And that's what I always thought. Because there's some creatures that can't live in the sun, under the sun's strength, which possibly should. If you were born and raised here, if you evolved here, if you were placed here, it would be completely different. Then that kind of that avenue of thought might be plausible. But I'm not saying it is. Understanding the scale of the problem. This is the vastness of space problem. The Milky Way is the galaxy that includes our solar system, with the name describing the galaxy's appearance from Earth. Looks like the Milky Way. When we look up at this hazy band of light seen in the night sky, formed by the stars in the outer bands, we can't individually identify them. It just becomes a milky mix of starlight, at least to the naked eye. The term Milky Way, outside of Nestle, is a translation of the Latin via lactea from the Greek, and I can't read that in Greek, galactikos kyklos, meaning milky circle. From Earth, the Milky Way appears as a band because its disc-shaped structure is viewed from within. Galileo Galilei first resolved the band of light into individual stars with his telescope in 1610. Until the early 1920s, most astronomers thought that the Milky Way contained all of the stars in the universe. Following the 1920 Great Debate between astronomers Harlow Shapley and Heber Curtis, observations by Edwin Hubble showed that the Milky Way is just one of many galaxies, since they were then able to see what other points of light were, and some of them were stars, some were galaxies. The Milky Way is a barred spiral galaxy with an estimated visible diameter of 100 to 200,000 light years across. Recent simulations suggest that oh God, here we go. I don't believe in dark matter at all. They can say it all they want. I'm going to read the text as though it's real. Recent simulations suggest that a dark matter disk, also containing some visible stars, may extend up to a diameter of almost 2 million light years. I just vomited a little bit into the back of my throat. Don't worry about me, I'll be fine. The Milky Way has several satellite galaxies, which is now also disproved that they're just galaxies but not necessarily described in science as satellite galaxies of the Milky Way. They're just other galaxies in our local group of galaxies, which forms part of the Virgo supercluster, which is itself a component of the Laniakea supercluster. It is estimated to contain 100 to 400 billion stars and at least that number of planets, because we've realized there's at least one planet per star. But sometimes you might have a group of planets to a binary system or a trinary system. The solar system is located at a radius of about 27,000 light years from the galactic center, on the inner edge of the Orion arm, one of the spiral-shaped concentrations of gas and dust. Astronomers have found the edge of the Milky Way at last. Our galaxy spans 1.9 million light years, a new study finds. There's an image, so let me just make sure that you guys can see it. And if I do middle screen, there we go. And I can even turn myself off there, so that's better. It says, in this image from the Fermi Space Telescope, the Milky Way's stellar disk, which runs horizontally along the middle, glows in gamma rays a vast halo of dark matter engulfs the disk and emits no light at all. Of course, we can't see it in any way, which makes measuring the galaxy's total size a challenge. No, it's an imaginative thing. I don't agree with it at all. So that's Fermi LAT collaboration DOE NASA. And now we have a story. We're going to put it back to this. By Ken Croswell, March 23, 2020 at 6 a.m. Why would you bother putting the time? Unless something was a discovery. Our galaxy is a whole lot bigger than it looks. New work finds that the Milky Way stretches nearly 2 million light years across, more than 15 times wider than its luminous spiral disk. The number could lead to a better estimate of how massive the galaxy is and how many other galaxies orbit it. And that's not true anymore. Now, in the last 5 years, we've discovered that they're not orbiting us at all. Astronomers have long known that the brightest part of the Milky Way, the pancake-shaped disk of stars that houses the Sun, is some 120,000 light years across. Beyond this, stellar disk is a disk of gas. A vast halo of dark matter, presumably full of invisible particles, engulfs both disks and stretches far beyond them. But because the dark halo emits no light, its diameter is hard to measure. Oh, Ken. Alice Disson, an astrophysicist at Durham University in England, and her colleagues have used nearby galaxies to locate the Milky Way's edge. The precise diameter of 1.9 million light years, give or take nearly 500,000 light years. The team reports February 21, 2020 in a paper posted at arxiv.org. To put that size into perspective, imagine a map in which the distance between the Sun and Earth is just 1 inch. If the Milky Way's heart were at the center of the Earth, the galaxy edge would be 4 times farther away than the Moon actually is. To find the Milky Way's edge, Disson's, I'm making up the accent, it says decent, team conducted computer simulations of how giant galaxies like the Milky Way form. In particular, the scientists sought cases where 2 giant galaxies arose side by side, like the Milky Way and the Andromeda, our nearest giant neighbor. Because each galaxy's gravity tugs on the other, the simulations showed that just beyond the edge of a giant galaxy's dark halo, the velocities of small nearby galaxies drop sharply. Using existing telescopes observations, Deason and her colleagues found a similar plunge in the speeds of small galaxies near the Milky Way. This occurred at a distance of about 950,000 light years from the Milky Way's center, marking the galaxy's edge, the scientists say. The edge is 35 times farther from the galactic center than the Sun is. Although, here we go again, dark matter makes up most of the Milky Way's mass. The simulations reveal that stars should also exist at these far out distances. Both have a well-defined edge. Deason says. The edge of the stars is very sharp, almost like the stars just stop at a particular radius. It's like the table just appears to have a sharp defined edge and just seems to stop at that particular distance. The universe versus the observable universe. The size of the whole universe is unknown, and it might be infinite in extent. Some parts of the universe are too far away for the light emitted since the Big Bang to have had enough time to reach Earth or space-based instruments, and therefore lie outside the observable universe. In the future, light from distant galaxies will have had more time to travel, so additional regions will become observable. However, owing to Hubble's law, regions sufficiently distant from the Earth are expanding away from it faster than the speed of light. Oh, here we go again. I'm going to say right here, right now, that I believe the nonsense around the expansion of the universe is clouding people's ability to see it rationally. And I'll explain it after I finish. However, owing to Hubble's law, let's read it again, regions sufficiently distant from the Earth are expanding away from it faster than the speed of light. Special relativity prevents nearby objects in the same local region from moving faster than the speed of light with respect to each other. But there is no such constraint for distant objects when the space between them is expanding. It's the space that's expanding, they say. See uses of the proper distance for a discussion, and furthermore, the expansion rate appears to be accelerating owing to dark energy. Right. So I've finished vomiting on myself here because that's complete nonsense. I had a theory, and I found the simplest explanation that the Doppler effect is that it's the reason why people are claiming that the universe is expanding is because everything away from us is in redshift, and redshift is accelerate. The further away the object is, the more redshift it has. Therefore, it must be going faster away from us. And that sounds fantastic. What a great use of Doppler. What if the redshift is not caused by the speed at which it's moving away from us, but rather because, and the same scale, it is age of light that could be causing the redshifting. Light might deteriorate in wavelength, therefore appearing to redshift. It could be the appearance of redshift caused by the age of the light. And then when you start to make that determination, then you see why that you can't see objects past visible light with visible light anymore. It's gone into the infrared because that's redshifting. And then past infrared, the distance we can possibly see with the infrared, it's invisible. So you go down into radio waves, and then you can start to see them. And that also forms the same depreciation of the wavelength of the electromagnetic scale from visible light, infrared, down into radio waves, and microwave. It all makes that same scale curve. So the scale curve that allows us to see further also fits the same description as there being just simply the age of light. And I found a website recently. That was my theory. And I found a website which also has a description of the depreciation of light's wavelength. And thankfully, if we marry those two ideas together, the whole reason for dark matter is eliminated. So they had to create dark matter as an imaginary thing, because we can't test it, to make their theory work. Mine doesn't require any imagination or creation of anything fictitious in order for mine to work. I believe mine is the right one. But I'm happy for comments below. Hate me if you like. If pass it on to your physics professors. I don't care. Let's have a discussion. Let's get them on. I'd love that to happen. Anyway, moving on. Did you say Cool Whip? Cool Whip or Cool Whip? Cool Whip. Observable universe. That's one of my favorites. I just love it. I'm so passionate. This is a visualization of the whole observable universe. The scale is such that the fine grains represent collections of large numbers of superclusters, The Virgo supercluster, home of the Milky Way, is marked at the center, but is too small to be seen, which gives us an amazing scale. And this scale across, if you're watching this on YouTube or Rumble or anywhere else, 93 billion light years across, which is equivalent to 28 billion parsecs. And if you're a Star Wars fan, parsec is a term of distance. And if you're a real fan, you'll understand how Han Solo brags that he did it in less than so many parsecs, is in the amount of distance to escape the maze of that zone that he was going through. He did the Kessel Run in less than how many something parsecs. So to be able to escape it in the least amount of moves is the brag, not the speed. The observable universe is a ball-shaped region of the universe comprising all matter that can be observed from Earth or its space-based telescopes and exploratory probes at the present time, because of the electromagnetic radiation from these objects, has had time to reach the solar system, or the observable instruments, and Earth since the beginning of the cosmological expansion. See, the whole expansion idea is also based on the Big Bang Theory, and that's based on the Doppler effect and the redshift, and just maybe it isn't at all any of those things. Isn't that really interesting? There may be, says the text, 2 trillion galaxies in the observable universe, although that number has recently been estimated at only several hundred billion based on new data from New Horizons. Assuming the universe is isotropic, the distance to the edge of the observable universe is roughly the same in every direction. That is, the observable universe has a spherical volume like a ball centered on the observer. Every location in the universe has its own observable universe, which may or may not overlap with the one centered on the Earth. Once again, it's a ridiculous statement. I like some of that statement, but not all of it. Just because we're in the middle and that's as far as we can see doesn't mean that the person over here is also limited to the same ball shape where they're not in the middle. The idea that every single person in this ball, if every single point of grain of sand of light here is their own center to their own ball, it would paint a very large image of what this universe, the actual universe, is. And the fact that we've claimed that it's expanding and the distances are expanding between them all would mean that we just all fade into nothingness. Nothing would ever pull us back. Ridiculous notion. I completely detest it all. Happy to have an argument with someone against me. That'd be great. The Drake equation, one of my favorites, because it doesn't rely on dark matter. The Drake equation is a probabilistic argument used to estimate the number of active communicative extraterrestrial civilizations in the Milky Way galaxy. Just our own one. The equation was written in 1961 by Frank Drake, not for purposes of quantifying the number of civilization, but as a way to stimulate scientific dialogue at the first scientific meeting of the Search for Extraterrestrial Intelligence, or SETI. The equation summarizes the main concepts which scientists must contemplate when considering the question of other radio communicative. It is more, there's a bit of text missing, it is more properly thought of as an approximation than as a serious attempt to determine a precise number. Criticism related to the Drake equation focuses not on the equation itself, but on the fact that the estimated value for several of its factors are highly conjectural. The combined multiplicative effect being that the uncertainty associated with any derived value is so large that the equation cannot be used to draw firm conclusions. Isn't that an irony? You make an equation which its outcome is an estimate, and the number is still very large about the amount of civilizations that could be in our simple Milky Way galaxy, the one we live in our home galaxy. The number is still large enough to be thrown away. Oh, it couldn't possibly be. Oh, it's too big. How could you possibly have that many active, current, communicative civilizations out there? That means civilizations that are currently in the same window of being able to communicate that we are at with radio signals right now. Not excluding the ones, I mean, this is not including the ones that haven't reached radio yet, and not including the ones that have surpassed it. Just the ones that could use and communicate with us right now. And the number is so vast, so big, that they've just thrown it in the bin. Oh, it couldn't possibly be that, so let's just ignore that, huh? Isn't it crazy? So I'm going to display the Drake equation for those that can zoom in or see it in full screen. It basically talks about the different things that should be included to determine whether something can be counted, and that is the average rate of star formation. So how readily stars are made, because every star has planets. So the fraction of those stars that have planets, well, we know that it's every star has planets, unless it's in a binary, then it's shared with another star. But if you called them star systems rather than a single star, then that would be all of them. That would be 100%. Then the average number of planets that could potentially support life that star has. And we've known that most stars have a planet in the habitable zone. Some are too big, some are Saturn-like. But if you think about the types of stars that could have life and are in the Goldilocks zone, so then you've got the fraction of planets that could possibly support life that actually develop life at some point. And you also, there's a consideration here, it's very sciencey, says the fraction of planets with life that actually go on to develop intelligent life. And then there's that fraction again of those that made it that far, that have developed technology that releases detectable signs of their existence into space, i.e. like we did with radio and TV signals. And then the length of time for which such civilizations release detectable signals into space. So we're almost at the point where we're not going to be transmitting anything anymore. Isn't that extraordinary? Because we were transmitting an analog, fully high-powered stuff going out everywhere, in all directions. Then we started down the path of doing cable, and now we're doing digital. We have everything now. And the internet is taking over. So I could see a point in the next not so many years where we turn off all terrestrial transmissions. We could be using quantum-based communications where you quantum entangle two photons, for instance, or two electrons, and you separate them apart. It doesn't have to be two. It could be, you could have a cluster of 1 million electrons that are all entangled together, and you pluck one electron out of that group and you put it into, say, like a data center, and you call it particle 1. and the rest of the 99, for instance, they then get distributed to individual devices, for instance. And the vibration or change in that original electron that you've got stored away in a cage in some base station will replicate instantaneously to each of those other electrons. And if you did this en masse with trillions and trillions and trillions of these electrons, it would make a whole bunch of sense that you would no longer ever need to transmit anything in any way, shape or form, because they do the transmission for you. And testing, like observing, not testing the two of them together, but they remain entangled, so you change one and the other one changes straight away. Isn't that crazy? We could do that and we could turn off all transmissions. And they're secure, no one can hack it. I love it. Anyway, I can't believe that that's the end of the second hour already, and I've only got to page 7. Love you guys. Keep listening. Do like, share, subscribe, and comment. Be safe, everyone, and we'll see you again next Sunday and also Tuesday at 7 a.m. for Plato's Cave. Oh, and catch our reels. Do like them, share them. Take care. Bye.